Hello everyone, welcome back to my channel. I am Nitya from Sri Venkateshwara College of Engineering, Bangalore. In this video, let us learn something about the programming language that is known as data structures and application. Queues. A queue is a linear data structure that follows first in, first out principle. Elements are added to the end of the queue and removed from the front. Queues are used in various applications such as scheduling, task management, and resource allocation. Operations performed on queues. Implementation of queues. We can implement queues using arrays, linked list, and circular queues. Arrays. Queues can be implemented using arrays where front and rear are the pointers which are used to keep track of the elements. Circular queues. In circular queues, the rear and front pointers wrap around the beginning of the queue, allowing efficient use of memory. Complexity analysis. NQ operation in a queue implemented using arrays has a time complexity of 0. DQ operation in a queue implemented using arrays has a time capacity of 0, that is 0 or n, as it requires shifting all elements. Queues implemented using lists having a time complexity of 0 for both NQ and DQ operations. Applications of queues. CPU scheduling, pointer spooling, BS. CPU scheduling. Queues are used to manage the execution process in an operating system. Pointer spooling. Queues are used to handle multiple print requests in a sequential manner. Graphs in a breadth-first manner. Priority queues. Priority queues are variation of queues where elements are assigned priorities. Elements with higher priority are dequeued first. Priority queues can be implemented using arrays, linked lists, and binary heaps. Real-world examples for queues. Supermarket checkout lines. Customers from a queue and ticket booking systems. Customers wait in a queue to purchase tickets for events or flights. Call center support. Incoming calls are queued and answered by the agents based on their availability. A stack is a linear data structure that follows last in, first out, that is LIFO principle. It is a collection of elements with two main operations, that is push and pop. The push operation can be used to add elements at the top, and the pop operation can be used to remove the element at the top. Stacks are commonly used in programming languages, that is recursive algorithms and undo-redo functionality. Here are some of the key operations which we are going to use in stacks. That is, push operation adds an element to the top of the stack. Pop operation removes the top element from the stack. Peek operation retrieves the top element without removing it. Implementation of queues. Let us know how can we implement the stacks. Stacks can be implemented using arrays or linked lists. If we have to implement any stacks, we can take the help of arrays and linked lists. In arrays implementation, a fixed size array is used to store the stack elements. In linked list implementation, each node contains the element and the reference to the next node. Stack visualization. Imagine a, imagine a stack of books where the topmost book is the most recently added. When you add a new book, it becomes the topmost book. When you remove a book, the book below it becomes the new topmost book. Stack applications. Function call stack, which is used to keep the track of function calls and return addresses. Expression evaluation. Infix to postfix conversion and evaluation using stacks. Andorido functionality in text editors and graphic softwares. Time complexity of stack operations. Push and pop operations takes. Stack operations are efficient and have a constant time complexity. Here are some of the disadvantages or limitations of stacks. Those are stacks have a fixed size in array implementation, storing function call information and local variables. Heaps are used for dynamic memory allocation, such as storing objects and data structures. If more elements are added than capacity, there may be a chances of overflowing when there are elements more than the capacity while implementing the stacks. Dynamic resizing can be used to overcome this limitation. Stacks are not suitable for searching or accessing elements in the middle. Stack follows LIFO principle. Queues follows first in first out, that is FIFO principle. Stacks are Stacks and queues are both linear data structures but with different behavior. Though stacks and queues are linear data structures, they behave differently. Stacks are ideal for reversing or tracking the order of elements, while queues are suitable for handling process in the order of arrive. Stacks